solve. And I remember specifically on the test, even though there was one like this on the review, this was probably still the most commonly missed solving one. So if that was the commonly missed one on that unit test, if it shows up on our test, it's probably going to be one of the more missed things, but you can avoid that. But the main thing is you got to know how to start this off. So you need to think about, all right, I've got two natural logs that are separated with addition, and you can condense addition into multiplication. And I think that first step is really, the deal breaker there. People who thought to do that got most or all the points, and the people who didn't know to do that spent some time, were confused, and probably didn't earn any points because it's hard to go on from there. But condense that with multiplication. Then this side is natural log of some stuff, and this side is natural log of some stuff. So the natural log parts are already balanced. So then you just need to make sure that these inside parts are equal. So if you were to FOIL this, and then realize you have a quadratic, so you should get all the x's, everything on one side set equal to 0. So this would make 1x plus 8x, 9x. Okay, that gives you a quadratic to solve. And I'm going to hope that I don't have to use quadratic formula here. I'm going to hope that it factors, but I guess we will see. Yeah, so I should move that over too. So that would make this a -5. Okay, and that's good because then it factors. Again, we can always use quadratic formula, but I don't do that unless I'm sure that everything else is fine. So where this equals 0 could be an answer, and where this equals 0 could be an answer. However, there is one other piece to logarithmic equations, is that some of these answers could be extraneous. So my reasoning's good, my factoring's good, my solving's good, everything's fine, but some of these, or both of these, or none of these could be extraneous. So you have to imagine if you were to plug in 1/2 into the original equation, you have to make sure you're not taking the log of 0 or the log of a negative number. And right here, plugging in 1/2 is a problem, because the natural log of -1/2 doesn't exist. So this is what we call extraneous. The algebra just created a solution that doesn't actually solve the original equation. But if I plugged in -5, well, -5 minus 1 is -6. That's also negative, so I'd say he's extraneous too. So did we get no solutions on this? Somebody have the answer key out so they could check it quickly. Just to make sure there was not anything else wrong.
Yeah.
So it's pretty rare that neither one of them work, but neither one worked because it gave us the log of a negative number. Can't take the log of 0, you can't take the log of a negative number. If you think about a logarithmic graph, they don't exist at 0, and they don't exist for any negative numbers.